Welcome everybody to our kickoff meeting for our ISS Rideshare project. And there is a short agenda for this first session. We've had our introductions from everybody. Then we're going to go through what is our goal, our final goal with this project. We're going to begin with the end in mind. We'll have a look at the timelines. And then, yes, let's go back to the beginning. Where do we start with our STEM kits and our first projects? And then what I'm also going to do is I'm going to mention that we have scheduled educator training workshops 2 weeks from now. And then also what are we going to prepare for our next workshop? So we've had our introductions, and yes, let's begin with the end in mind. So here I have a picture of the NanoRacks NanoLab itself. This is actually 2U, so it's 2 CubeSat units. So one CubeSat unit is 100 by 100 by 100 millimeters, and that is by far the most used standard for satellites, is the CubeSat. So this particular unit, with it being a 2U, it's 200 millimeters high by 100 by 100, and that is the outside dimensions. So what we need to do is we need to fit inside. And Bianca, I know I'm putting you on the spot here, but I was wondering if maybe, if I stop sharing, if you can maybe find that NanoLab and show it to everybody, if that is okay. There we go. Okay, so for the video, I have pinned Bianca's screen. So what we have over here is the NanoLab, and you can see what happens is that all of the different payloads actually slide into that. So we can accommodate 14, absolute maximum 16 of those payloads. And here Bianca is actually showing us very similar to what was actually flown on the high altitude balloon project with NASA that Jim took to New Mexico, Jim took with his students. And so what it is that each payload slice then slots in to form that. So this was an engineering model that Bianca was working with before having the final model that he sent through to Jim. So Bianca, thank you very much for that. What I'd like to do is I'm going to remove that pin now, and then everybody has received your STEM kits. So everybody has received STEM kits as well as add-on sensor kits. So Mike, I was just wondering if you wanted to just have a look there, what you have, Mike Wallach, if you wouldn't mind just having a look there to make sure that you have 2 types of kit. Do you have STEM kits and do you have add-on sensor boxes?
I've got
advanced add-on. Okay.
These
great. So Susan, you and your team have already seen the STEM kits. Susan's team from Greater Lowell Technical High School actually won an award last year with the Department of Education on their space challenge, and so they received a number of kits from us. But Amanda, for you as well, when you open up the STEM kit, you will see there is this black MaxIQ chip. What you do is when you turn it around, you'll see there's a QR code that takes you to the Getting Started guide. So everything that you need to know getting that kit started is on this QR code on the back of this black X chip. Okay. So what you have in your STEM kit is with everything that you're going to build on this program. And whenever you want to build a scientific instrument, whenever you want to build a payload, what you need is 4 different elements. types of element. You need input, which is always going to be some kind of sensor, which is going to collect data as an input. Then you need output, processor, and power. Yes, so what you have is in that standard STEM kit, you have 3 different sensors. Okay, you have the soil moisture sensor, which you're going to be using in and around school and at home, but you're not going to be using this one in space. Okay, so you have the soil moisture sensor, you have a light sensor. So this is going to give you natural light intensity as well as UV index. And with your next round of hardware that you're going to be receiving within the next month, you're going to have an additional light sensor, which is also going to give you color of the spectrum, red, green, or blue. Is that correct, Bianca? RBG, red, blue, and green. Yes. Red, blue, and green. Absolutely. So light sensor, and then you have a weather sensor. And the weather sensor is going to give you air humidity as well as air temperature. Okay. And Bianca, if you wouldn't mind putting into the chat the link to your GitHub page, which describes and has the specifications for all of the X chips, and what, according to each symbol, just so that it's easy for everybody to identify. The reason why we have symbols on the X chips is, and we don't actually write what it is so that it can go across languages and it can go across different alphabets, etc. Because we run a global program, we have to be very careful that we're not excluding anybody. Right, so we have inputs. We have inputs, and then in your advanced add-on kits, you'll find that there's a barometer. That's really great. That gives you atmospheric pressure. And from that, you can also calculate altitude. It will also give you an air temperature reading, which is really quite useful. So if you don't want to use the weather center, you can use the barometer as well. You have the accelerometer. So this accelerometer is going to give you acceleration, X, Y, and Z. In South Africa, we say Z, like in zebra, X, Y, Z / Z. Okay. And you can also calculate G-force, pitch, yaw, and roll. And this is really great for measuring microgravity when you're in orbit. You also have, and I wonder if I have an example here. Yes, I do. This is a gas sensor. This will give you volatile organic compounds as a gas concentration, as well as carbon dioxide equivalents. So this is really terrific for measuring air quality, especially inside closed rooms, this gas sensor. And so that is what you have in your add-on kits. And then you also have a large selection of perf boards so that you can actually add your own sensors to those boards. Bianca, do you have some examples on hand of some sensors that you found elsewhere that you've added to those perf boards in that advanced add-on kit?
I do.
But you need to dig them out. Okay. While you dig,
I have them.
Okay.
I have them here. So first of all, I have this new board here for Jim. So Jim, this is this do quick connects and stemma. So like the prototype board you did last time, this thing here you can connect directly. And I have some example of that right here. So here I have 2 examples. So you can see this is 2 Adafruit sensors that connected. So I just used a big knot here to make a standoff. I have to find my finger here. And then it comes with standard 1-inch separated holes, because that's what Adafruit and SparkFun uses on their different boards. So I don't have the wire yet, but you can imagine the wire is connected to the white connector from on the board to the black connector here. What we had before that, Jim used last time, was that we have a board like this thing here, where you can just use any kind of prototype board, and then you use some wires underneath to kind of like configure how these pins, that's not necessarily any specific order on the board, how they matches the pins on our board. So that's the one way. And then there's the super duper way, that's using a big perf board like here. We kind of like call it the Mike Galvin board, because he kind of like came up with this thing here. And on the latest NASA flight, he used one of these boards with 3 sensors on it, and that way connected to it. And you can see that you have all the same pins here. There's like a list of the different connections you have here that will allow you to kind of like put together your own sensors if you so desire. Judy?
Great, Bjarke, thank you so much. So if we don't have a sensor within our ecosystem that you would prefer to use, you could always get something from SparkFun, Adafruit, and actually add it to the boards. And because it uses the same connector, runs I2C 3.3 volts, then you can add it to the rest of your circuit. So we've had a look now at input. Then what you need is you need output. So with your STEM kits, you've received this ESP32, the little robot face in the bottom right-hand corner. This is what it looks like. So this is your processor. And in your STEM kits, it's been pre-flashed with Arduino code. So as soon as you put those STEM kits together, that it'll run as a weather station. Okay, so it'll work straight out of the box. When you want to add the other advanced sensors, like the barometer or the accelerometer, something like that, in the Getting Started guide, you will see that there is code where you actually start, that you need to add to include those sensors. But don't worry too much about that. Just get your standard STEM kit up and running, run some experiments, because soon what you're going to be receiving is you're going to be receiving the core that we're going to be using with our flight hardware. So I'm going to show you a comparison with that. And so now, of course, I've dropped it, but it doesn't matter. So built to last. If it can't survive dropping on my floor, it can't survive going to the ISS. So you can see here, this is the core that you're going to receive with a more updated processor on it. So Bjarke, do you want to explain this board? I can hold up the two where I compare them. You're on mute, you're muted, Bjarke.
Thank you. So the big difference is that the old board that Judy have, the one that have the 6 buttons on, that one, it's that runs ESP32. The new one runs ESP32S3. So the same software run on both boards. The only difference is that you have to tell where the I2C bus is. I know it sounds complicated, but it's one line of code that you have to tell. The good news is that the new extended core that you're going to use on the flight, and I'm coming back to that, uses the same pins as a new core. So this exact same code will work on both of them. You can literally take the binary code from the one to the other. So the new extended core and the new standard core runs the same processor and the same pins. What it also has is that it has 2 LEDs. One is a NeoPixel, that means it can show RGB colors, so you can use any kind of colors, and the other one is just a standard pixel red LED. And it has 2 buttons on it, so it didn't have the touch buttons on it like that. So we didn't actually need the 6 buttons for most of what we do. So instead of having those 6 buttons, we just have 2, and then you have the one that have the play button on the top, which is the one we use for our normal software. So we use it with like a single click, a double click, a long click, and that way you can use it multiple different things. And the button below is a reset button. So that's instead of you, you know, take the power on and off, or if you have to reset or something, you just click on that button. It also doubles as a button for putting into various programming modes. The other thing it has is that it has a USB port on it, a USB-C port, so you can program it directly. On the old board, you needed like an interface. Judy, I can hold one up if it is, but you needed a programming interface like this thing here. That's an old one. So let me just say, yeah, there's a good one there. So that you needed to program the old core. The new core, you don't need that anymore. You can just program it by plugging into a USB-C directly in the side. And maybe the most interesting part is that it also have a expansion port, so where you can plug in. So I have a board here that you can where I just demonstrate here that there's an SD card plugged in. So you can see here that I have an SD card that sits in this thing here, and the same port can be used to put a lower radio in, and actually our new ground station solution is actually not much bigger than actually just one chip with a radio in. So I made, like, for example, a ground station solution here. So this is actually the lower radio down there that sits in a core. The rest is just battery solution that I put into this. This is a solar panel thing that can run by itself without any other power. So that's the big difference. And Judy, can I continue with the extended core?
Yes, please.
Okay. So the normal core that we've been using on a different flight that Mike and Jim is familiar with is this one here. It have a SD card built in directly. It has this extended plug here that with the SD card or the radio. It also have a camera port, so you can use a camera on this thing here, and the camera can use, you know, either to record, you know, pictures or video, but you can also use it for machine learning. So you can use it to kind of like recognize different kind of fruits and things like that. There's a number of different projects for machine learning on that. It also have PS RAM, so there's more memory which you need for doing recording a video, because it goes so fast that you need to store it. And then it have what's called a CAN bus transceiver that allows it to communicate once we are in space with our with other participants. So the new one that we're using, so the one I just showed you here is a green version, and the only reason I'm holding it up this is because this is the core that you're going to fly with. It looks almost the same, but it's just a bit narrow, as you can see here, because there's no space inside. And also you can see it's a bit shorter if I hold it like that. Sorry, I just had to find the camera. So it's a bit shorter. And what that means is that there's only 2 connectors on this thing here. This is my up, by the way. There's only 2 connectors. And that means you can connect the 4X chips on your flights on the ISS. Or, of course, you can put in like a prototype board, and then you can plug in as much as you can squeeze into this board here. So that allows you to put more in than just our 4. But if you're not comfortable with that, then you have room for 4 X chips up here. There's a SD card, sorry. There's a SD card here. So that goes out to the side. It's an upgraded version of the SD card holder compared to the old one. It sits here on the edge, so once it's installed into the container, it can't actually by mistake come out, because the nano lab is kind of like the wall of the nano lab is here, It's have the USB-C here. It also have the PS RAM. The only thing it doesn't have, because of the smaller space, is it doesn't have the camera port. But then again, it's inside a dark container, so we kind of like didn't think that camera port was important for this thing here. But it have all the other things. It had 8 megabyte memory, both flash memory and 8 megabyte PS RAM, allowing you to do the crazy stuff. It's still a dual core, so you can do all your stuff, 240 megahertz, so it's a very fast core, and the USB. The USB allows you not only to program it over USB, but you can also do USB stuff on it. So you can program this thing as it works as a memory stick, Mike. So that's the way we communicate. We're using this thing here to communicate with the boss on the International Space Station, because they are connecting to our whole cylinder and expecting us to operate like we were a memory stick. So we have it here, and the code is done and things like that. So we can communicate with all the different devices on board using this edge connector. And then the data we get, we then store on an SD card here that we then operate as a memory stick for the server, for NanoRex's server on the International Space Station. Now, I know a lot of this thing here is very hectic to listen to, but just so for those who's used to our stuff, they want to hear the new stuff, obviously, and for you guys that haven't are familiar with any of this thing here, don't worry. We will come back to a lot of this thing here again and again. So if you didn't get all that, you will get lots of opportunity to catch up on these different things. And I maybe just have one thing more, Judy, if I can share my screen. Is that all right? Just have to say
you should be able to, yeah.
Okay, that's fine. So I'm gonna share this. So on the screen here, we've done this window here, and what it allows us to do with a new core is that we can install a UF2 bootloader on this new core. What that means is that we can actually do a drag and drop, and we can make like ready-made software. So down here I have a little list. So for example, the tiny ground station, MicroPython, I have I2C scanner, and I have some software we do for the Quest. That's the supersonic airplane. We have done some software for that. And you can then simply drag and download the UF2 file, and then you can plug in your core, and it will look like a memory stick, and you simply just drag and drop the software to that. So you don't have to use MuEditor or any of these things that you used before. So that's with the new core. So you guys are the first one to actually use the new core, but that's the one we're going to fly with on the International Space Station. So therefore, I think it's just important that we have that with. Can we ask for questions before I hand it back to you, Georgie?
If you don't mind, I just want to go through output, processor power, etc. Okay. So I'm just going to share my screen again. So we go back to that slide that we had. So yeah, so you have input from your sensors. So you have many sensors that you've received, a lot to choose from, and you can use those perf boards to actually add more. However, with the International Space Station, you're only going to be able to have 4 of these sensor boards, of these MaxIQ sensor boards, or otherwise, if you use the large perf board, you can add as many as you like. The output, when it comes to the STEM kit that you've received, the output that you have, and this is all in the Getting Started guide, so don't worry if you're not writing it all down. But with the STEM kit, the output you're going to be using is actually your OLED screen, And this core as well, with all the cores actually, I have also got Wi-Fi as well as Bluetooth connectivity. So that is actually how you can use that as an output. When we have our International Space Station project, you're going to be outputting your data to that SD card. So it's really important that during November, once you've received your new core and your new extended core, that you start writing code so that you can actually write it effectively to your SD card, because that's really where it's going to count. So what you're going to find is, as soon as you put your weather station together from your STEM kit, and if you plug it into a USB power bank, it is going to work. It is going to run straight away because it's already pre-flashed with Arduino code. What it'll do is it'll start displaying data on your screen. So it's not easy to see here, but you can see that my screen is lighting up, and it's actually outputting there. Let me actually try another one that's going to display a little bit better. If you just give me a second. Here we go. So the thing is that what you can do, you're going to be using these little connectors, these little 10-pin connectors. So as you can see, what you do is that you just click it together. The getting started guide will actually show you which way around they need to be, and then you can chop and change. You can add another sensor, you can take away a sensor, etc. So yeah, it's gonna. There we go. Now I'm just covering the one light so it doesn't overpower it. But I think you can see here now it's starting to run and display my data. Okay. So also, when you go through the getting started guide, you'll see that you can also output data to a Kibana dashboard, and you can run many experiments. 2 weeks from yesterday, actually, we are going to have some educator training. So if you want to join for that, I will send out that invitation, and then we really go through the workings of that STEM kit in all that detail. And in terms of power, with your STEM kit, you do have this USB-A unit. And then when you receive your flight hardware, that you can also use with USB-C as well as this USB-A. So you've got more options to power it. When we're on the International Space Station, you don't have to worry about power. We are going to provide the power. So that is one less thing for you to worry about. So what do our timelines look like? These are the workshops that we're having. So today, this is a repeat of the workshop yesterday. All of these times are Eastern Standard Time. And as I mentioned, 2 weeks from now, we are having 2 hours, which we're repeating. Once again, we're going to repeat it on those days, 2 hours of educator training workshops. So for those of you who are educating others, I would highly recommend that we get together so that we can actually take you through all of that and exactly how everything works. Then what we're going to do is, between now and the next workshop, which is actually officially workshop 1, November 5th, and repeated again on November 6th, is what we'd like you to do is we'd like you to use those kits that you have received and run a number of experiments. So what you have is you have a multitude of sensors with data that you can. So what we would like you to do is discuss some ideas of what experiments can we run where we're collecting natural light intensity, air temperature. Maybe we want to look at a correlation between soil moisture and air moisture, relative humidity, things like that. So what I'm going to be doing is that over the next few days, I'm going to be sending a number of ideas for experiments. However, what I would really recommend is that you find your AI large language model tool of your choice, and you design a prompt where you say, this is the data that I can receive from my sensors. I'm going to be using an ESP32 to process my data. Recommend some experiments for us. And you'll be really amazed at the ideas that come from these different AI models that you can consider. And the reason why we want you to run at least one experiment is we really want you to get used to the idea of clicking together these modular electronics and how they work, and the whole ecosystem and how that works. Because what we're going to be doing is, in our November workshop, we're going to start having a look at payload design and what is the experiment that you're going to be conducting, so that we can go through research question design and how actually do we design that experiment that we're eventually going to run on the International Space Station. So we've got a number of workshops. Everybody has the schedule. I have shared a Google Sheet with everybody, and in that we have the schedule. So we have over this project, we have at least 8 workshops, and with each one we have a different goal of what we want to achieve with that. At the moment, what we're planning for is that sometime around about like early to late December, we have a look at another balloon project where you can have your payload connected together in a rideshare option, like Bianca showed earlier. Bianca, please, if you wouldn't mind just showing that high altitude balloon option again. There we go. You are muted, but that is perfect. Thank you. So what we will do is we will be able to slot in everybody's preliminary design. And what it'll do is it'll fly on a balloon project. We're not sure exactly what altitude that we're going to achieve, but it'll certainly be higher than 15,000 feet, which is 5 kilometers. So anywhere between 15,000 and 100,000 feet. Or 5 to 20 kilometers. And what's really going to be important then is you're going to be testing how well the data writes to your SD card, because we're going to recover it. You're going to get your SD card back, and then you can see how well it has actually written the data there. Sometimes what happens is that when the kit is powered up, sometimes it overwrites the data. So you just need to be really careful that when you design your code, that what it does is it creates a new file each time. But there are a number of participating teams within the broader group who have done this before, so they can certainly help with that, so that you don't end up with those challenges. And then in terms of the future deadlines that we have, we do have a deadline where at the end of January, you need to tell us if you are go or no go. In other words, are you going to be ready with your experiment by the end of March? Because what we need is we need all of those experiments by the end of March, so that we can put them through their testing. We can integrate them into that nano lab and get it to nanoracks for SpaceX, because they need it a number of months before it's going to have its flight. So as it stands right now, we're probably going to have the flight during July, possibly as late as August in 2025. It will go with SpaceX on a resupply mission to the International Space Station. It'll stay there running your experiment for 46 weeks. And then it's all going to be returned with a cargo Dragon with SpaceX. And then everybody's going to receive their payload back. And then you're going to have a look at your data. So Jim, I was wondering if you just wanted to share some of the experience that you and your students had with the high altitude balloon project. And when you received it back and you opened it up and all of that. So how was that experience?
Yeah, it was great. I mean, we designed it and we learned a lot because we had done some model rocket stuff before with MaxIQ. So we wanted to up the ante and actually like attach a different sensor. So Björka really helped us figure out how that works, because my students aren't used to like electronics at all. Some have, some haven't, but we don't have a class for that. So worked on, well, you know, soldering and all that stuff and got it to work, programmed it. It actually worked. We were super excited. Sent the package to you. The package came back, all assembled. Yeah, I don't have it here, but then we took it out to New Mexico, which was a blast. Got to sightsee out there. We also got into the NASA facility, attached it to the gondola and everything. And then, unfortunately, we missed the actual launch because of weather. It got delayed almost 2 weeks, so there was no way for us staying there and knowing exactly when it was going to go off. But that was an exciting morning going to see it. Then it finally launched. We got it back and opened the box, and there was the actual payload, but it had a ton of dirt in it. Like they literally just picked it up off the ground, put it in. So there was all this, you know, orange reddish dirt from the New Mexico desert on it. So
yeah, so thank goodness we won't have that challenge, because
Yeah.
there's no dirt on the International Space Station.
No. So that was good. So we took it all apart, got the boards, you know, got all the information off the boards, and we've just been having a blast actually analyzing the data. And then we just made a discovery yesterday about the data, which will be exciting to show in tomorrow's data sharing meeting. But it was funky little data at some point up in the stratosphere. We're like, what is that? And it turns out we might have figured out that we detected the plume from an Alaskan volcano. We're trying to figure out, yeah, you'll see it. I finally put it together yesterday when we were going through the data again and like, what is bothering us? Anyway, it's a whole story we could tell, but yeah, between CO2 and we didn't know what we were going to get. We just expected normal, and some of the data was normal, like temperature, then others weren't. And then it's launched us in this whole investigation of what could explain these results that we weren't expecting. But it's not like the chip wasn't working, because the chip was working and other chips actually showed similar data, because we had several different chips on there that were looking at CO2 and stuff. So they were showing similar stuff, correlating it. So it was just amazing to see like all the different experiences the kids have gotten out of there. And so we were actually talking to people, because we presented this last week. We didn't know about the explanation for some of the funkiness yet. So we just kind of left that to the side. But what we ended up doing is talking to one of the NASA guys. He goes, you need to publish this. I'm like, what's there to publish? Now we think we have some cool stuff that could validate models. So we actually, Cody is actually looking up some information for us, seeing if he can get some of the models for that volcano plume and see if they match up. So kind of exciting stuff. You just never know what you're going to get into with this. So this year, we've always done it on our own in engineering, but now we kind of want to bring in the biotech class into the excitement. So some of my students are helping that class figure out what they might want to do as an experiment. So we're going to do 2 chips for engineering and 1 for biotech and 1 for the chemistry classes. So, you know, just building the excitement of the project and bringing more people in and exposing more of the students to that. So I don't know, did I hit everything, Judy? I don't know.
That's fantastic.
That
is really great. Yeah, so Jim, that's going to be really exciting feedback on that project. So yeah, let's make a video of that feedback and then share that with everybody. And that's definitely something that you could be publishing, and presenting at a number of different forums. So that's really interesting. One of our previous trips to the International Space Station, it was actually quite unfortunate because all of the SD cards on that particular trip, they had glitches on them when they came back, and when they actually looked up what had happened, then there was actually a solar flare, and what had happened is that the solar radiation had actually affected the data collection over that period of time. So that actually picked it up without knowing what they were picking up. And that's the great thing about data collection, is that you collect the data and then you just have to analyze it in a very empirical way to say, well, what is it actually telling me? I can't have any preconceived ideas of what it's telling me, but let's try to work out what it's telling us. So that is great. So what I would encourage everybody to do is please have a look at that shared sheet. If there are colleagues of yours, if there are team members of yours who need to be added to the distribution list, what it is actually what I should do probably is, let me find that. It was a Google shared sheet, so let me just see if I can pick it up here, and then I'm going to share my screen. Okay, let me go here. Okay, so ISS Rideshare. Okay, so let me share this again. I probably need to zoom in a little bit. Let me just zoom in a little bit. Okay, so what we have is we have the first tab has the participating groups. Then what we have is the third tab. I'm going to go there. Here we have the schedule. So it goes all the way through to workshop number 8, which is once we've received our kits back from the International Space Station. And then what we also have is we have a mailing list. So what I wanted to do is that I wanted to make sure that everybody who needs to be included in the different workshops is on this mailing list. So if you wouldn't mind, everybody who has access to this list also has editing rights. So please just put onto that list everybody you feel who needs to be invited to the workshops. And also there is the schedule here, so that you can really have a good look at that. Should you feel that you need to have an additional session with us, please simply let us know. Give us a week's notice so that we can schedule something for you. Bianca and I are very happy to give as much support as you need on this project, so that it's a great experience for you, and it's not frustrating at all. It's great if it's challenging, because we all love a good challenge, but we don't want it to be frustrating. So if at any stage you want to have some kind of a catch up with us, please simply pop me an email and we'll make that happen. So right now, do we have any questions? I can see there's something in the chat. Jim, please ask your question directly, because it's a question for sure. Bianca and possibly Mike Galvin.
Yeah, will we have a downlink to share data on? It probably won't be great, but like at least send some of the data so that like if there is a solar flare type event, we don't lose data type thing.
Yes, there will be a downlink. So the downlink, so of course, the bandwidth to the ISS is limited. Sorry, we're not the only one who is on board the ISS and have a project running there. So the way it's going to work is that you're going to develop your software as is. Mm-hmm. And when you get your extended core, will provide a communication to another core. So you will be able to simulate the communication on the ISS. And for that purpose, I'm going to do a library, Arduino library. So you simply just have to, in your code, in your setup, you have to call one line of codes where you kind of like identify yourself. And then you will have another library call where you can send the data. It's going to be very limited how you can send the data. And I'm going to, document exactly how that data is have to be put together. What happens is that that library function is so you can communicate from your boards over the bus. So you will be running on one of these layers, and you will then communicate via this panel here in the back to the control board down here. And that control board is then connected via a USB to the server that NanoRacks have on board the ISS. And they remote control the server and have a uplink there, where they can then take the file that our solution have as our whole solution will look like a memory stick. And I will then be able to take that file and I will download it and I don't know, email it to us or something like that. We don't know exactly how that part works, other than we know we have to operate as a memory stick, and we have that part of the code we already done and have that working. So the only thing we just have to figure out from them is that how much capacity we have, if it's like a megabyte or 100 megabyte or a kilobyte or whatever, but how much it is. And we then split it between the participants, and the way we're gonna do the call and things like that will be kind of like set up so it limits it so you can send that data. But the only things you have to do in your code is that you have to do one line of code in the beginning and then a line of code for that data to be transferred to the memory, to our memory stick that will work as a USB-C memory drive. So you will have that, so you're not 100% reliant on your data on the SD cards. The other thing that I just want to say also is that you have the option, because the board has a SD card on board here, but unlike you could actually in our own one, but we didn't have the board, you can actually connect an extra SD card in. So you can write to 2 SD cards at the same time. So you can either, kind of like mirror it. So you have 2 times 32 gigabyte, which is probably sufficient because you only have, you're only up there for a month. And I promise you, once you get to 100 megabytes, it's going to be tough enough. Or you can have it as a 64 gigabyte if you really think you have that much data. But I suggest that you write to both these. It uses the same call, the one in the other SD card. The only thing that changes is that you have something called a chip select, and that just selects the one and the other. The other thing is just if you are doing anything where you have a lot of data, fast data, so like accelerometer and things like that, this SD card that is that's plugged in here, so this one that plugged in here runs something called 4-bit MMC, and that means you can write like 10 times faster than normal SD cards. So you can write super fast like it was memory, but only on the SD card that sits here, because it uses all the pins. That uses 6 pins. This one here operates as normal SD card, so you can kind of like use that for backup. So if you have anything special that, for example, readings from the accelerometer, you want to do that like, you know, kilohertz or something like that, you need something very fast to write to, and you can do that with that. And the reason why it's configured like that is because our normal little core that we have, so the core we have here, it has the same port, and it's exactly the same, so it's the same software, so it will also write very, very fast on the standard core on that one. It just don't have a separate SD card like you have here, but there is this SD card slot that you can use for that kind of stuff. Jim, I hope I answered the question.
Yes, yes. And then I got to get running to another meeting, but do we have lessons learned from the SD card that got corrupted? Like, is it dead when it hit the solar flare hit, or was it? So that's something to discuss, but I have to get to another important meeting.
Great.
The short answer is that we couldn't recover anything.
Okay. Very good. That's good to know. Okay, we'll have to design around that then. Thank you.
Yes.
Yeah.
Thanks,
Very good.
Jim. Cheers.
Thanks. Bye-bye.
Okay. Yeah, I've got a couple quick questions. Number one, so are we exposed at all to the outside space environment, or is this all the internal environment of the ISS?
You're not even exposed to the internal environment on ISS. You are isolated inside a container. So there's very limited. There's no light other than if you put some light on your own board or anything like that. So obviously it's not hermetically sealed. So that means that the temperature and humidity and things like that you have on ISS, you will also have inside the box, okay? But it is a sealed off box, but it's, as I said, it's not like sealed purposefully to be pressurized, sealed and things like that. But for the safety of the astronaut on board, they don't want something that's open. So all experiments on ISS, except like maybe like something specifically that the astronauts have kind of like requested, but all the third parties that have experiments running, they're all send containers up there and it's inside that. But for example, when we had some stuff on the ISS last time, we used the accelerometer and we picked up like vibration, and we were like in a container where, you know, there was other experiments running. So we actually picked up some fumes for that other experiments. So there's other stuff that happens. But yes, you have very limited, you pick up very limited environmental information, but you do have the same temperature, humidity, pressure, and probably CO2 level and things like that. There is on ISS simply because it's not, airtight. The thing is that you probably have to see, because you run this project over months, so it will probably be kind of like a curve where you kind of can see that it changes from, you know, Earth atmosphere to the atmosphere on board the ISS over time. So it's going to be interesting to see. The other one we had last time when we flew was like hermetically sealed. This one here there's a lid on top and bottom, and even though they're tight, they only hold together with 4 screws, so it doesn't seem like there's any like stuff that particularly hold out. It's more like a screw doesn't fly out of this thing here and, you know, interfere with the stuff on ISS. Any kind of other stuff comes out. So that's how it is.
Yeah, and then just one more thing. So the hardware that we have now is not the flight hardware. Is that correct? Like the kits that arrived today?
Just hang on, Mike. You had additional answer to that.
Yeah, I was going to chime in also, just because we're really poking at what is especially interesting about this environment. And of course, the easy answer is it's real microgravity, it's real zero-G environment. But the other aspect we're trying to dig into a little bit, my students here at Princeton, is we expect the radiation environment, while not as bad as a free flying spacecraft, is probably still quite a bit worse than sea level on Earth, even behind multiple aluminum walls in the ISS. So some of my students are trying to do radiation experiments, even deep inside the cabinet. So that's an available option for groups trying to take advantage of the real space environment.
Gotcha. No, that's super helpful. And then I guess kind of the last two questions there is the hardware that we have different from the space hardware that will fly. And then if we put our own sensors on the perf board, is that still something that would fly to the ISS, or is that just for our learning practices?
If you put something on a perf board, sorry, Judy?
Yeah, I just the only thing that is different is the core processor. So this one that you have right now, you're getting an upgraded version, and it's that upgraded version of the processor that's going to go to the ISS. Everything else is going to be the same. All of the sensors are exactly the same, etc.
Judy?
So yes.
Judy, he was asking
Yes.
if we put something on a perf board. So if you put something on your on that board, it will go to the ISS.
Okay.
Yes.
So
Can I chime in
yeah.
also, Bjarke?
Yeah.
Just warning people ahead of time that the aspect that you might want to be aware of is that the thing people always want to do in microgravity is biologicals or chemicals, and that would probably be challenging for this program just because of some of the safety red tape imposed on MaxIQ by an experiment like that. So in the past, we've developed some guidelines for this sort of thing, like some guardrails as to where the limits of your perf board experiments should be. I don't think we have that published quite yet, but the first time we get wind of anybody doing interesting perf board experiments will probably be our excuse to put together some guidelines like that. But the short answer is probably no biologicals, no chemical experiments, and supplemental batteries are not a non-starter, but certainly a paperwork safety challenge.
Okay, but if we're strictly sticking to I²C based sensors, that kind of thing is okay. Yeah. Okay.
Yep.
Yeah. So the thing is that you can. So the answer here, and Mark is completely right. There's no biological, no chemistry, no battery chemistry, no RF, so no kind of transmission radio signals or anything like that. You can read data, and you can't actually conduct the experiment. You have to pick up environmental data. That's kind of like the thing. You are able to run SPI. You can do one sensor SPI, and then you use another prototype board like one that looks like this thing here, and that can slot into that expansion port that I showed you before. So instead of the SD card you have here, if you for some reason need a SPI sensor, let's say you have something that can only run SPI, you can put it on a prototype board like that, and then it's getting slotted in there on that board here. So you actually that way have, you know, even a sensor more if you want to do that, and that can run SPI. It can also run I²C, but just so you have that option. The biggest restriction is that you have only 8 millimeters of space from the surface of the board to the next board above you. So you just need to make sure, and that's the thing here where now you can see this thing here start getting a little bit too high. I mean, there's some pins that I could probably cut off to kind of like get within the 8 millimeter restriction. But in order for us to kind of like keep the costs down, we have to squeeze in as many experiments as possible. And you're in a bunk bed here with a lot of others, and you have with your own board 9.6 millimeters, so there's 8.8 millimeter between the boards. So we're using standoffs that's 8 millimeter tall, so that's kind of like a hard limit to kind of like make sure that everybody can be in there.
Bjarke,
Mike, you turn the camera on, so you will say?
Yeah, we're getting in the advanced weeds here, but just clarifying, can you also run a serial device over the edge connector? I think there's one serial bus on the edge connector as well, right? Or is that hard?
So the nice thing about the ESP32 is that you can run I2C, SPI, and serial over any pins. So you can there's 3 pins on that port, on this extended core here. Sorry, on this expansion bus here. There's 3 pins here, and you can configure them as serial pins. So you can configure that to connect serial. You also have serial on the normal XBus pins.
Yeah,
so you have serial on that.
Yeah.
And then you just can't use this one here, okay? But because you can use the USB, then it's fine. But this uses serial also. And sorry for you guys that are not used to any of this stuff here. This one was with the original core, and it was the only way you can program it. Now with the new core, because you can program a USB over USB-C, you have a spare serial port that you can use. So you can definitely use that on the perf board also. I mean, there is actually IX and TX on the perf board also.
Okay, I'll stop confusing and scaring everybody who hasn't played with the kids yet.
Don't worry. If it's not you, it's probably going to be me. I just want to say, Judy, can I talk about UCT? You're on mute.
Yes, if you like, Bianca. It's just we're at least 12 minutes over time. So
Okay, I'll be very quick. But this is maybe interesting.
I mean, if anybody needs to leave, thank you. You're not being impolite by leaving.
So we're working together with our local university. They have done a gamma counter, so it counts the gamma photons or gamma particles. So they have developed a gamma counter that they have in a container like this thing here. This uses in the tube, and this use a very specific sensor. And they want to have that put on X chips. So together with them, we are actually working on. I'm basically doing prototype on this thing here, so it's not ready yet. But this thing here will be able to do gamma and neutron radiation counting. Now, I'm so green in the whole radiation thing, so I have no clue if it will work behind a aluminum container compared to some of the other radiation that Mike is talking about. But we certainly probably going to try and see if we can get something out of that. So it's a project we started a month ago, so we're still very much in prototype phase and hope that we can have something available. But otherwise, we're only guaranteeing the sensors we have now. Okay. Any other questions?
Great. Okay. Thank you, everybody. And I'm going to be doing an edit of the video, and I will be sending that out to all of you, a link to that to all of you. And I'm also going to be sending out the invitations to the educator training workshops as well as the next workshop in November. Please remember, reach out at any time, and we can certainly set up a session for you.